All right. Hi. Welcome to our video on electrons and atomic radius. Hopefully you have your notes page ready because here we go. Okay. So before this, you might remember that we learned the periodic table can tell us how many protons an atom has just by looking at it. So I'll give you an example here. Right, if we zoomed in on this corner of the periodic table, we would see a little number above each element. So for lithium, we see a number 3, and that tells us that that element, an atom of lithium, has 3 protons. And the same for this element here. If we look at the periodic table, we would see a number 4, and we would know an atom of beryllium has 4 protons. Okay, so that goes for any of these. For example, we could look here at gold, which is number 79 in the periodic table, and we could say gold atoms have 79 protons. Okay, so that's the thing about elements is they always have the same number of protons. So this beryllium atom, for example, has 4 protons. It's always going to have 4 protons, but the number of electrons can be different. So protons, always the same. Electrons, not always the same. That's kind of what today's about, okay? So, yeah, the number of electrons an atom has can be different. And the periodic tells us how many electrons, like most of the atoms, has. So, for example, for beryllium, let me just close this here. For beryllium, right, it could have 3 electrons, it could have 4 electrons, or it could have 5 electrons. All of these are beryllium atoms because they all have 4 protons in the middle there, those blue guys, but they have different amounts of electrons. Okay, so that's what I mean when I say atoms of the same element can have different amounts of electrons. The periodic table tells us how many electrons an element has, but it only tells us how many electrons one of those versions has. So these are like different versions of the same atom. You could kind of think of it as maybe, I don't know, if you had, 2 twins or something, if you were part of like triplet set of people, then that's you. Okay, so the periodic table only tells us about one of those atoms, not all the different versions. Okay, so how do we know how many electrons an atom has? You know these numbers tell us how many protons, and the thing is, they also tell us about how many electrons there are. Okay, so here's the start of your actual notes page. We're going to be talking about something called electron shells. So, an electron shell is a word for just the area around an atom's nucleus. So if this was an atom, this red part in the middle, that's where all the protons and neutrons are at. Okay, that's the nucleus. And the electron shell is just this area where we see this little electron whizzing around. Okay, so an atom can actually have multiple electron shells. In this animation, there's just one shell, like there's one area where the electron is. But bigger atoms, like this uranium atom, can have 7 shells. You can see these 7 circles here. So atoms can have 1 shell, they could have 2, 3, 4, 5, 6, or 7 shells. So there's a certain amount of electrons that can fit in each of these shells, okay? So this first shell, we can fit 1 electron and then 2. And after that, this shell is very small. And so after that, you can't put any more electrons in it. They just won't go. Okay, so the first shell can hold up to 2 electrons. So write that down on your notes page. Okay, so once we have 2 electrons, if we want to add any more to this atom, then we have to have another shell. So we would add a second shell. And we can put more electrons in there. And we can fit actually up to 8 in this second shell. It's bigger than the first one, so we can fit more electrons. So that second shell can hold up to 8 electrons. All right, and then I'll just skip forward to the third shell can also hold up to 8. Okay, we're not going to get any bigger in this class, so I'm not going to have you making huge atoms. That would be a lot of drawing, so we're just going to stop here at the third shell. But what I want you to do on your notes page right now is try to fill in that little atom that you see. I'll skip forward here. Try to fill in this atom on your notes page, okay? So if I told you a chlorine atom has 17 electrons, right, what would you do first? You would go to the first shell, right, and you'd say, well, I know that first shell can hold only 2 electrons. So you'd draw 2 electrons, and then you'd say, well, I need to go to the next shell because I can't fit 17 electrons in this first one. So you know the second shell can hold up to 8. So you could go ahead and draw 8 electrons in there. But we still only have 10 electrons. We need to put 7 more on our atom. So then you would go to the third shell and you would draw 7 electrons. Okay, so you wouldn't draw 8. Even though this last shell can hold up to 8, you only need 7 more, right? So we have 17 total electrons. Okay. So this was my example here. Okay, this is what a full shell would look like, but you don't really need to worry about that. This is just me telling you a little review here. First shell can hold 2, second one can hold 8, third one can hold 8. All right, so I did have you practice with a partner in class, drawing different kinds of atoms. So for example, I would say, a carbon atom has 6 electrons. What would that look like? Draw a carbon atom. Okay, so if you want to, you could pause and try that on your own. If you feel like you get it, we can just keep going. Okay, so for example, nitrogen atom. If I was like, a nitrogen atom has 7 electrons, right? You would draw 2 in the first shell, and then you would move on to the second shell and draw 5 and say, yep, I did it. That's what a nitrogen atom looks like. Okay, we're just going to skip ahead here a little bit. Now we're going to think about the size of atoms. In other words, their radius, okay? So we did an activity with Legos. You won't get to do that, unfortunately, but you can finish your notes page. So flip over your notes page. We're going to talk about atomic radius. So radius is a word from math class. You might remember. It's just a fancy word for like how big is half of a circle, right? It's related to diameter. So in this case, in chemistry, it really just means how big is the atom. The bigger the radius, the bigger the atom is, okay? And you'll see This is a version of the periodic table that shows you how big atoms of the different elements are. So you can see the atoms towards the top here are really small compared to the ones at the bottom. And atoms that are on the right side of the periodic table are a little bit smaller than atoms on the left side. So atoms on the left side of the periodic table and towards the bottom are going to be the biggest atoms. All right, so if you can remember these arrows, like going down, they get bigger, going to the left, they get bigger. Go ahead and draw those arrows on your notes page. Okay, and this is a little less important for you to know, but I do want to tell you, in case you're like, why are atoms different sizes? Well, it has to do with how many electron shells they have, right? So it makes sense. The more electrons an atom has, the more shells it needs to fit those electrons around it. And so in the periodic table, as you go down, you get more and more electrons. So you need more and more electron shells, and thus you get bigger. Okay. Um, this concept is actually a little bit complex, I think. So you can skip this question on your notes page that says, why does radius decrease from left to right? You don't need to answer that question. Okay. And just a little background here. So why do we care about how big atoms are? Well, it affects how reactive they are. Okay, so the bigger the atom, the more reactive it is. And this is what we mean when we say reactive. Does it explode when it comes into contact with water? Does it catch on fire when it comes into contact with air? So, in other words, does it react with other elements around it? Okay, so the bigger it is, the more reactive it is. So, these elements here in this corner are the most reactive elements in the periodic table. Okay, I'm not going to show this video, but we're going to skip rather. Okay, so if I pulled these elements out of the periodic table, these are all in the same column, and I asked you which of these would be the most reactive, you would be able to tell me potassium is the most reactive of these three because it's closer to the bottom of the periodic table. And I know that atoms get bigger as you go towards the bottom, which means they're more reactive. Okay, why is this? Why are bigger atoms more reactive? I'm going to explain this with an analogy. Okay, so imagine, right, protons are in the nucleus of the atom, and then electrons, right, are whizzing around on the outside. And they're attracted to each other because they have opposite electrical charges. So kind of like magnets are attracted to each other, right? North and south, positive and negative are attracted to each other. Okay, that's why electrons stick around and like fly around in atom's nucleus all the time instead of going off and doing their own thing because they're attracted to that positive proton in the nucleus. Okay, but the thing is, the further an electron gets from the nucleus, right, that attraction starts to lose its power. So the nucleus can't hold on to that electron as much if it's far away. It's like, hey, come back here, electron. So this is kind of like walking a dog. If you've ever walked a dog that isn't very calm, it's really excited, it's easier to control that dog if the leash is really short. If the leash is way too long, that dog can go off and do whatever it wants, right? It's harder to control the dog the further away it is from you. So electrons are also like that. The further it gets away from the nucleus, the harder it is to control what it does. And that makes this atom really reactive because then the electron goes off and it does other things with other atoms. Okay. So the bigger the atom gets, the further away the electron is and the more reactive that atom is going to be. Okay, so try to answer the question on the bottom of your notes page. What element do you think would be more reactive, beryllium or rubidium? Okay, beryllium is towards the top of the periodic table. Rubidium is towards the bottom and further to the left. And that's it for this video. Nice job.